Hello everyone, welcome back to the channel. So today we'll solve the daily challenge from Leetcode. So you can see the question over here. Design graph with shortest path calculator. Okay. So this is a hard level question, and let's see the question. There is an directed weighted graph that consists of n nodes numbered from 0 to n minus 1. The edges of the graph are initially represented by the given array edges, where edges of I is equal to from I to I and the edge cost. Okay, meaning that there is an edge from I to I with the cost of edge cost I. Okay, so this is contains the edges array. Okay. So implement the graph class. So we have you can see that three classes. You can see the graph class over here, and you need to implement the graph class. And in the graph of int that means 2D vectors of 2D array of edges. Initialize the object with n nodes and the given edges. That means this will initialize the graph of n nodes with the given edges. Okay, so then you can see that add edge is there, which will add the edges after creating the graph. Okay, like in this case, we need to write the function for that, which is adds an edge to the list of edges where edge of is equal to from the element to where the when we need to connect the edges, and the edge cost will take for adding the edges, and it is granted that there is no edge between the nodes before adding this one. Okay, so the next thing is int shortest path, int node 1 and int node 2 is given as the arguments. Okay, which returns the minimum cost of our path from node 1 to node 2. If no path exists, it will return minus 1. Cost of the path is the sum of the costs of the edges in the path. Okay, so in this case, we need to find the shortest path. Suppose this is the graph, and maybe we want go to 0 to 2. Okay, so we can have two ways to go 0 to 2. 2 is the destination, 0 is the start. Then you can say that if we go through the 0 to 2, we need 5 cost. Okay, the cost is 5. And if we go to the 2 via 1, that means 0 to 1 first, 1 to 2 first. That means we will have the 2 plus 1 as the cost, which is the 3 is the cost. So we'll return this cost. Okay, yeah, we need to return this path. That means 0 to 1 to 2. This will be the shortest path. Okay, so and suppose you can see that in the graph case we will give an integer and the 2D vector, and we need to make an adjacent list to make this graph, and then we'll have given a shortest path. You can see 3 to 2. 3 to 2, how can you go there? That means there is only one way, which is no, there is two way, which is 3 to 0, then to node number 2. Okay, this is the one case when where the cost will be 5 plus 3, which will be 8, and let's say another way, which will be 3 to 0 is 3, then 0 to 1 is 2, which is 5, then 1 to 2, which is plus 1, is 6. So this is lesser than the previous one. So we'll take this path as the minimum path, okay, or the shortest path. Okay. One test case is there, and let's see how can we make this thing. Okay, so let's create a vector, 2D vector with pair, because we want from the node to the node and the cost of the edges. Okay, so in and let's do 1, 2, 3. Okay, perfect. Okay, so let's give the name as adjacent list. Is it okay? Yeah. Let's initialize the uh, adjacent list, which is adjacent list dot resize, which will help us to resize the whole adjacent list. Okay, which is n. Then we need to add the edges. For this thing we'll use auto, then we'll have an edge. Let's see the edges. So how can we add these things? Let's see. Adjacent of list, which will start from E of 0. Every edges, there will be three cases from 2 and edge cost. Okay, so then for this case, the edge cost will be adjacency list of the first node or the second node or the every node, which will be the from node to push back. We are pushbacking the pair, like make a pair. Without this, we cannot make the pair in C++. Then we'll just keep the age of I and age of 2 to initialize the whole thing. Initialize the whole, adjacent list. Okay, we have created the adjacent list. And then what do we need to do? That we need to make the add edge where every uh, we can add edges. Okay, so let's see how can we create that. So we don't need two things, nothing too much. That in the adjacency we just add the edges from the where the from node and the to node and the cost node. Okay, so let's do this adjacent list we and the edge of 0, which will push back, not the pushback, because we already have the existing node. So we'll use the equal to sign, and then we'll have the make pair, which will take age of 1 and age of 2. Okay, I hope you understand this part. And that is why that is how we'll add the edges in the graph, and then we need to find the shortest path. So for finding the shortest path we'll use this algorithm. If you don't know, just google it and learn how to do this. And we are just implementing the Dijkstra algorithm here to find the shortest path of a graph. Okay, so how can we find the shortest path? So before that, let's find the array size, the list size. Okay, n is equal to adjacent list dot size. Okay, then we'll find the let's take a cost for node. Okay, okay, which will be the size of n, and the every cost will be int max, which is the infinite for the first time when we'll just traverse every element, every node. Then we'll just check which is the minimum, and we'll just do uh, for the till the n number of times, because we have n nodes. Okay, so let's have the priority queue to check every item in the ascending order. Okay, then vector, okay, vector int, then vector of vector int, and we need another thing is greater int, which will check for ascending order, not int here. We need a vector in a sorted order uh, by using the priority queue. So let's declare the name as pq. Then let's make the cost for node for the node 1, which is the from node, from where to we need to go to the node 2. So the cost of node will be 0 because this is the starting node. So now we need to push the first value in the priority queue, which will be 0 because the cost of node is 0, and the node 1 because this is the starting node. And we'll check every time that while PQ is not empty, the priority key is not empty. Till then, we'll just use this loop to find the exact value. Okay, let's declare the current cost, which will be the uh, PQ priority queue dot top of 0 will be the current cost, and the current node will be which is the PQ, again PQ dot top, and it will be the one first index, which will be the one index. Okay, no, and we'll just see that if current cost is greater than the cost for node, which will take every cost of PQ, not PQ, which will be the current node. For that case, we'll just tell them don't move forward and go back and check for the next element. Okay, if we find our current node is equal to the destination node, which is node number 2, we'll just return the current cost because this is the value we wanted, that wanted the minimum cost. Okay, so the current cost will be written over here, and then what we'll do if this is not that current cost value is the greater than previous value, or this is not the destination value, then what we'll do? We'll just add all the neighbor elements, neighbor nodes to our priority queue and check for them, and after that we'll get the perfect answer. So what can we do for auto? Let's take neighbor, and in the neighbor we'll check for the adjacent list for what, for the current node. Okay, is it? Yeah, then we'll check that the neighbor node, which is, let's take neighbor node is equal to the which I've taken as neighbor dot first, and we'll check the cost also, which will be neighbor dot second. Okay, and let's find the new cost. Okay, new cost will be the uh, cost plus. Okay, if new cost is lesser than cost for node of the neighbor node, then what we'll do? We'll just replace the value, replace the cost to find the minimum cost. Then cost for node of any IGHG or UR neighbor node is equal to the new cost. Okay, is it? Yeah. Then we'll add this value into our priority queue. And priority queue will set everything in the ascending order. Okay, so pq dot push, which will be the vector, and for the case we'll just pass the new cost and the neighbor node. Okay, so we'll just do it, and it will just give return the current cost if we haven't got any kind of path, and that means if there haven't any path between to node 1 and node 2, then what we'll do? We'll just return a minus 1. Is it? Yeah. Okay. I hope you guys have understood this solution, and let's run this code and see what we'll get. We got an compilation error. So for this case, I think we need to use pushback because we have done something wrong. Because every time this is a vector and it will add as a vector. That's why we need to do this. And the vector will be a pair. So we need to push back every time. And I hope now it will run successfully. We are getting time limit exceed. Okay. Oh, PQ is not popping. Okay, PQ dot pop. Let's see right now. We are getting an error not. Okay. Yeah, you can see this is a accepted code. And let's submit the code. And let's see. Okay. This is now let's find out the time complexity of this code. So from here we can see for the initialization, uh, almost we suppose we have v vertices and e edges. Then for this case, the time complexity for initialization will be O of V plus E, which where V is vertices and each edges of a graph, and we just use the for loop. Okay, and for add edges, you can find that every time when you will add this case, it will just push back, but it will go up to n times. So the time complexity for add edges will be O of n, where n is the counting and is the n times it will happen. Time complexity for the shortest path will be a little bit tricky. So for this cost for node, we need to check for v, that means the n times, which is the number of vertices. So this will be O of v for this case. Then we know that the time complexity for this algorithm will be v not v, e log v, and we can consider that the time complexity for this case is O of V plus E log V. Then we can also know that the shortest path will call up to m times. Let's suppose. So for this case, the time complexity for the whole thing will be, let's write time complexity. Okay, will be O of, let's suppose we'll call up to m times. Then, as I told earlier, v plus e log v, e log v. Okay, this is not comma. It will be multiplication. Okay, so this is the time complexity for the shortest path function. Okay, so after calculating these three time complexity, we can uh, find out the overall time complexity, which will be you can see I am writing over here, and which will be O of n, which is the number of times the nodes have there, and it will be and the shortest path. Okay, is it? Yeah, this is the correct time complexity. Okay, so what will be the space complexity? For this case, the space complexity will be O of, you know what, E plus V or V plus E, everything is same, because it's just checking, it's just the cost of the adjacent list, okay? And then the edge will be the, let's find out the space complexity, which will be O of n again, because uh, it's just adding where the time constant will take only of one, but it will check up to n times. Then for this case, it will be the cost will be the space complexity will be O of n. And for the shortest path, as I told earlier, that for this case, we'll go up to the v vectors, and for the priority case, we need up to e edges. So for this case, the space complexity will be O of V plus E. Okay, so the overall space complexity we can add three of these, which will be E plus V plus N plus E plus V. So we don't need to repetition. We don't need any repetition. So the space complexity will be O of V plus E plus uh, plus N. Okay. Okay, so we have find out this time complexity and the space complexity of this question of this problem code, and I hope you guys have understood everything in this code. And thank you guys for watching. I'll see you in the next time. Thank you.